Manufacturing, transportation, energy, and utilities, among others, are some of the most critical industries driving a nation's economy, and industrial control systems are at the heart of any industrial operation. Industrial control systems ensure that the components used for production, handling, and distribution of any industrial output perform their functions accurately and efficiently. Many of these industries have been around a long time and have well-established systems, assets, and processes built around what's called OT, operational technology. But these industries are also affected by the rapid digital transformation of everyday life for both consumers and enterprises alike, through the increasing use of information technology, or IT. IT is all about data, processed, transformed, and stored by software applications, and accessed and transferred through communication networks. One consequence of the digital transformation of traditional industries is that IT is now increasingly entering the world of OT. Such industries see new efficiencies and reduced operational expense when adding IT capabilities to existing OT components and processes. For example, mechanical sensors and actuators are increasingly being replaced by more capable, programmable Internet of Things devices, such as smart sensors and meters, connected wirelessly to control systems using standard Internet protocols, or using remotely controlled robots to automate steps previously performed by humans. The use of IoT in industrial settings such as manufacturing, energy, utilities, transportation, and so on is called the industrial Internet of Things. This growth of IIoT is what we mean when we use expressions such as smart factories, smart buildings, smart cities, and so on. But enterprises should be aware that smart solutions bringing IT and OT together in industrial settings add new security risks. These arise from the different angles from which IT and OT users look at vulnerabilities and threats. IT systems are built to prioritize security of data above other features. Data at rest or in motion is protected from tampering or eavesdropping. Only then do IT systems ensure that applications are available for use when requested, but OT systems emphasize safety and availability first, because unexpected downtime can lead to financial loss, or worse, loss of life or property. OT systems have typically dealt with data confidentiality and integrity through the use of isolated networks and proprietary hardware and software. AT&T helps companies secure their OT and IT assets as they transition to the world of IIoT. But before we discuss various security threats and vulnerabilities of IIoT solutions, let's examine the main targets of cyber attacks, the industrial control systems. Every industrial process uses industrial control systems, or ICS. It's at the heart of every industrial application and comes in many forms. An ICS ensures that inputs to a process accurately lead to the desired output, meeting a specified performance. Industrial control systems come in various forms, depending on what and how many entities are controlled. At the top, we have SCADA, or Supervisory Control and Data Acquisition Systems. These collect data from many sources at a central site. For example, a SCADA system might collect environmental data from many building management systems, or BMS. In turn, a BMS might use a distributed control system, or DCS, to monitor and control all the thermostats on a single floor of a building. At the smallest level, we have programmable logic controllers, PLCs, which manage and control the behavior of individual components. For example, a PLC monitors and controls OT assets, such as a robotic welding arm on an automobile factory floor. In the past, ICS deployments were secured through isolation, leaving critical OT components unattached to any network, and using private, point-to-point links when communicating using proprietary protocols, while deployed on specialized hardware with custom-built software. But IIoT introduces all the security issues associated with current IT systems, as most IoT devices are built on off-the-shelf hardware and well-known operating systems. Use standard protocols such as TCP/IP for data transfer, HTTP for data access, and usually wireless networks for connectivity. Thus, a typical IIoT environment must be made resistant to IT threats and secured against the failure of critical ICS infrastructure arising from this integration with IT capabilities. Let's look at some cyber threats in these hybrid IT-OT environments. An intruder with access to the OT network can inject fraudulent commands or set inappropriate thresholds for alarms on IoT equipment, which could disable the equipment or infect it with malware. As the Mirai botnet attack of 2016 showed, unprotected smart devices in a home or industrial setting injected with malware can be used as the launching pad for massive distributed denial of service attacks, taking down websites and networks. Conversely, the intruder can inject false information or malware into the SCADA system, causing misdiagnosis of the local situation and forcing inappropriate actions on the controlled components. In a real-life example from 2015, hackers accessed the SCADA system of a power grid in Ukraine and turned off substations, plunging large parts of the country into darkness. Or, intruders can use the breach to get access to other unprotected systems in the enterprise's network, perhaps those holding valuable customer or company data. In a well-publicized example of such a breach, in 2013, hackers infiltrated the HVAC system of a major retailer, used it to gain access to the payment systems, and exfiltrated valuable customer information. Thus, no matter what the nature of the breach, industrial productivity is affected. But what is worse, attacks on critical infrastructure such as dams, power, or water filtration plants can harm people and property, with lives lost. AT&T recommends protecting OT assets in this hybrid IT-OT environment, using several techniques. Protecting communications links for connections between OT assets and SCADA systems can benefit from private VPNs set up over the open internet. That's easier than managing multiple private point-to-point connections across international boundaries. It's also possible to do this for mobile communications, as well as when the SCADA system is deployed in a public cloud. Data sent to IoT devices and other OT assets need to be analyzed at a machine transaction and data value level to prevent errant commands. This goes well beyond the deep packet inspection that typical enterprise firewalls offer. Also, security policies in place should ensure that the only authorized controllers can write data to IoT devices and OT assets. Back-office functions in an organization, as well as trusted partners, can only read data from OT assets to check the level of inventory at a plant, for example, but not be able to write data on them. OT data and telemetry can be formatted and consumed by IT applications, which enables predictive analytics to identify anomalies or to observe network traffic for patterns that might suggest ongoing rogue behavior. AT&T constantly examines the security risks inherent when IT and OT converge. It's more than just putting up additional firewalls. AT&T recommends a defense-in-depth solution against cyber attacks on industrial infrastructure. As the power grid breach, retailer consumer data breaches, and the Mirai DDoS attack show, commercial disruption and financial loss aren't the only potential risks from security vulnerabilities. Loss of critical infrastructure has the potential to affect lives. AT&T is committed to helping organizations maximize and protect their IIoT investments. As traditional industries take advantage of data-driven efficiencies by adding IT to their existing OT assets, AT&T is ready to help them tackle and deter new vulnerabilities that emerge. For more information on AT&T security products and services, visit our website at www.att.com/security-consulting.